Morning everyone, I'm Natalie Stanford and I'm here on behalf of FAIRDOM to talk about promoting and supporting fair data and model management in systems biology. As you may or may not know, FAIRDOM is a research infrastructure that supports researchers in better managing their data and models and also their operating procedures. When we're talking about helping researchers with better data and model management, we're really talking about the four tenets of the FAIRDOM project. First of all, we offer software to the community which allows researchers to manage their data from instrument collection through to publication. We also offer skills and capacity building and general dissemination of knowledge, and this includes working with standards groups. In addition, we have direct project support, which is where we work with researchers on a fairly frequent basis in order to help them manage and put in better protocols for their data management. And we also offer FAIRDOM Hub, which is an online instance of the FAIRDOM platform, and it allows researchers to manage their data there if they, for instance, do not have a huge amount of technical ability in the group, but it's also a place where researchers can go and find data, and it's also a place where people can start using data management without having to include any infrastructure in their own groups. Now, from what we've discussed so far, you may have realised that FAIRDOM is actually an acronym, and it stands for Findable, Accessible, Interoperable and Reusable Data, Operating Procedures and Models. Now, data operating procedures and models are really the information that we would help researchers manage, and findable, accessible, interoperable and reusable are the key characteristics that data is expected to have in order to be reproducible. If you want to find out more about the FAIR principles, you can actually read a paper called the FAIR Guiding Principles, and this will give you a lot more information about what each of the characteristics actually mean. The core FAIRDOM team is made up from research groups from 4 different countries. That's the United Kingdom, Germany, Netherlands, and also Switzerland. The FAIRDOM Research Project has also recently become an association, and this is based in Germany. The FAIRDOM project is supported by a number of different national funding bodies from each of the 4 partners. The FAIRDOM project began life supporting researchers in their data management in the SysMo project. Then FAIRDOM was known as SysMoDB. Since then, we started working with a number of different European projects and large consortia projects, and now we are a national resource in Norway, as well as supporting over 50 different projects with individual installations of FAIRDOM, and 88 different projects on the FAIRDOM Hub. Today I'm going to be discussing about how we support these research projects through providing standard tooling that supports them all the way through to publication. When researchers are generating and recording their data, we know that they do this in many different formats, and some of these will be standardized community formats such as SBML, CellML and ZML, but many others won't be. In fact, many models tend to be built in platforms using Python or MATLAB, and most day-to-day data tends to be managed with things like Word documents and Excel files. When this behaviour is amplified over a consortium, it makes it very difficult for researchers to be able to meaningfully exchange the information between each other without a lot of input from the original generator. And we classify this type of work as not interoperable or not reusable. There are a large number of standards available within the community that actually helps researchers to format, annotate, and describe their data in a more meaningful way. And this is for the case for models, data, simulation studies, and even results. We know that despite there being a broad availability of standards, that researchers don't always use them. And we're not quite sure why, although we do know that a lot of the standards that are in frequent use tend to be related to modelling, and this could be related to the fact that modellers have more computer and technical experience than their experimental counterparts. We also know that there is a lot more tooling available for supporting researchers implementing modelling standards, and it could be that really it's just the barrier between being able to easily implement these standards or not that is causing the disparity in uptake. From this we can glean that providing more software tooling to support the implementation of standards should overall improve research data management. Taking this on board, here at FAIRDOM we've developed a tool called WriteField, which allows researchers to embed semantic annotations within simple Excel files, therefore marrying better data management practices with the standard practices that researchers have in the laboratory anyway. The tool's very simple and allows researchers to create standard documents of metadata and then within this embed ontology terms into the actual cells within the file. This can then be taken by the researchers who are just filling in the normal data, and they don't even need to know that the semantic annotations are there. It will just be read computationally when they upload that work into appropriate software. Tooling like this improves how interoperable and reusable the data is. But what about findable and accessible? We know that researchers tend to store most of their data on their own hard disk, and very few of them actually use local research repositories for their institute, bespoke software, or even cloud-based systems so other researchers within their group can access the data. This becomes problematic if the researcher happens to move on to research at another group, or if they take time off for illness or parental leave. It's very difficult to then find the data in order to be able to use it for the rest of the research. It's not just unpublished data that happens to suffer from this either. In fact, it turns out from our research that a good number of researchers are not willing to share their data in open repositories even after publication, again making it more difficult to find the data in the first place. When data is managed this way, we classify it as not being findable, accessible, or reusable. In order to improve this, we designed the FAIRDOM platform, which involves a back-end called OpenBiz and a front-end called Seek, and these really help researchers manage their data pipeline from the point where they collect data from an instrument and through to publication. The main idea between these two different platforms is that they should encourage researchers into new and better behaviour in order to improve data management practices within their group from the moment they take the data off the instrument, and this should, over time, result in better data management practices in the lab. For many of the research groups we work for, this is a very standard looking pipeline, where we see the researchers have a data collection generator, which then imports directly to OpenBiz, and from here the researchers either decide to move the data and link it locally in a local version of Seek, or they can push the data to the online instance of Seek, the FAIRDOM Hub. Data that's stored locally can always be transferred across to the FAIRDOM Hub at a later date, perhaps after publication, and also we would recommend that a good chunk of data that isn't going to be publicly released should be archived accordingly. All of the projects use the Seek and also the online version of Seek FAIRDOM Hub to manage more finalised data and data that they're planning to publish. Seek is a content aggregator, and it allows researchers to link functionally their data, their operating procedures, and their models. They can also include metadata with all of this information, and they can also link articles that may have been published to data that's stored in Seek. Where they want to release data in external databases, they can actually publish this in databases such as biomodels and link them in Seek. Seek uses the ISA structure, whereby data and models and operating procedures are linked to each other through the ISA structure. This is the investigation, studies, and assay structure, where an investigation is the highest level of the ISA structure, followed by studies, which are smaller implementations of research that comprise your investigation, and then assays, which should be thought of as experiments. Each of the assays we would expect to have some kind of input and output data and be connected by a process, the process being the experimental procedure. When you have a complete investigation ready that you want to publish, you can take a snapshot of the investigation in Seek, which freezes the information in time. It still allows you to modify the investigation if you want, but you can always reach the original snapshot if you want to. These snapshots can then be assigned DOIs, which are permanent links that means researchers can always use the link to reach the original snapshot investigation. These links can then be added into research papers, and they behave in a similar way to supplementary material, whereby someone can click on the link and access the data. When someone clicks the link, they'll be taken through to the snapshot held within Seek. From here, the researcher can browse the different information associated with the snapshot and see the investigation in context. They can also choose to download the snapshot if they want to by clicking the little link on the right-hand side. Once a link's clicked, it then takes the researcher through to the research object view. The research object is simply a zip file of all the research packaged together. The research object can be downloaded from a link in the top right-hand corner. From here, it can be opened and browsed to identify all the different information contained within the package. The Seek also provides tooling that supports standardized formats such as SBML through allowing special functionality of models that are uploaded in this format on the platform. Models uploaded in SBML can be identified and then they can be simulated live using JWS Online. Once JWS has been launched, researchers can view the network of the model and they can also perform simulations live within Seek. These include time course and steady state analyses, among others. Researchers are also able to check out the differences between two different versions of models by using ByVes, whereby the researcher can scroll down and just click Compare for the model which they want to compare to the new version, and then they'll get a graphical format which shows what the differences are between the two networks. Through this support, we help make research data findable, accessible, interoperable, and reusable. In addition to this work, we've recently started a pilot with journals, whereby FAIRDOM has come together with JWS Online, with the idea of bringing reproducible modelling results to publications. Using Seek and SedML, we've come up with a way of connecting the simulation with the original data. So when you see a diagram within a publication showing a modelling result with some real-life data, you can then include a link below this diagram where the researcher can click and live reproduce the actual diagram. The results of the simulation can be downloaded using SedML, Combine Archive, or WebCat. Additional information that can be found on the live reproduction include the models and where they're held in JWS, the data description and where they're held in the Seek, as well as the simulation tasks that are recorded in SedML, and also the outputs which are reported in SBRML. And FAIRDOM isn't the only research infrastructure that's working on improving data and model management and reproducibility within systems biology and the broader life sciences. In fact, we're part of an ecosystem that all work together to ensure that reproducibility is of the highest priority in modern research. Thank you for listening to the presentation, and I'm looking forward to taking your questions in person now.